question number 41. In an experiment, the yield for the reaction of zinc with hydrochloric acid was found to be 40%. What minimum amount of zinc in grams should be added to 2.5 liter of 0.5 molar HCl to liberate 3.36 liters of H2 at STP? The mass of zinc is given to us. So students, we can clearly see that this question has the concept of limiting reagent as well as yield, and we can see that HCl is given in excess. So zinc has to be the limiting reagent. So let us try and write the equation first. So zinc plus HCl giving us ZnCl2 plus H2. So we can balance the expression. So zinc plus 2HCl will give us ZnCl2 and H2. Okay. So let us now look at the moles of H2 liberated. So it is given to us that 3.36 liters of H2 are produced. So the moles of H2 produced is equal to 3.36 divided by 22.4, which is equal to 0.15. So let us assume that the moles of zinc taken initially were equal to N. Okay. So it is given to us that the yield of this reaction is 40%. So it means N moles of zinc are going to form 0.4 N moles of H2. So 0.4 into N, it is equal to 0.15, which implies that the value of N is equal to 0.375. Okay. So this many moles of zinc are required. So we can figure out the mass. We just have to multiply the moles obtained above into its molar mass, which is 65.4. So on simplification, this will give us a value of 24.53 grams. Okay. So students, the correct option for this question is option 1. Looking at the next question, question number 42. A photon having wavelength equal to 500 nanometer is used for photolysis of a molecule X2, having bond energy of 144 kilojoule per mole. The percentage of the energy of photon which is converted into kinetic energy of X atoms is. So we have been given some conversion units. Hc is equal to 1240 eV nanometers, and 1 eV per molecule is equal to 96 kilojoule per mole. So let us first try and figure out the energy of the photon. So energy of the photon can be written as Hc upon lambda. The value of Hc given to us is 1240 eV nm. The value of lambda is 500 nm. So in simplification, this gives us a value of 2.48 electron volts. So what happens is a photon having this many electron volt energy goes and collides with a X2 molecule. Okay. And this X2 molecule is broken into 2X atoms. Okay. So some part of the energy of the photon is used up in breaking this bond, while the rest is transferred to the atom in the form of the kinetic energy. So let us first try and figure out the energy which will be required to break one single bond between X atoms. Okay. So the bond dissociation energy given to us is in kilojoule per mole. So which implies that this is the energy required to break 1 mole of bonds. But in this question, we have to break only one single bond. So we have to convert this kilojoule per mole into electron volt per molecule, as is the requirement in this question. So we have to divide this value by 96. So 144 kilojoule per mole will convert into 144 by 96 eV per molecule. Okay. So on simplification, this gives us a value of 1.5. Okay. So we can apply energy conservation on the energy of the photon. So the photon had an energy of 2.48, out of which 1.5 is used to break the bond, and the rest is transferred in the form of the kinetic energy. So the energy which is transferred in the form of kinetic energy will be equal to 0.98 electron volts. And if we look about the fraction of the energy which is converted into kinetic energy, that will be given by 0.98 upon 2.48 into 100. So this will approximately give us a value of 39.5%. So the correct answer for this question is 39.5, which is in the fourth option. Let us look at question number 43 now. P4 disproportionates in basic medium to produce PH3 and H2PO2 minus ion. What is the equivalent weight of P4 in this redox reaction? The atomic mass of phosphorus is given to us. It is 31 AMU. Okay. So let us try and look at the oxidation half and the reduction half separately. So in the reduction half, P4 will be converting into PH3. So we can write the balance expression as P4 plus 12H2O plus 12 electrons, giving us 4 PH3 plus 12 OH minus. Similarly, we can write the oxidation half for this reaction. In the oxidation half, the P4 will convert into H2PO2 minus ion, and this can be balanced as P4 plus 8 OH minus, giving us 4 H2PO2 and 4 electrons. So in the reduction half, the total number of electrons involved is 12, and in the oxidation half, the total number of electrons involved is 4. So we'll have to multiply the oxidation half reaction by 3, so which will cancel out the electrons eventually. So students, we can see that in the redox reaction of 4 moles of P4, 3 from the oxidation half and 1 from the reduction half. So in the redox reaction of 4 mole of P4, the number of electrons involved is 12. So we can find out the N factor for this conversion. The N factor will be equal to 12 by 4, which is equal to 3. And correspondingly, we can find out the equivalent weight. So E is equal to the molecular weight upon the N factor. So it is 31 into 4 upon the N factor, which was equal to 3. So students, we can see that this value will simplify to 41.33, which is given to us in the first option. So students, the correct answer for this question is option 1. Let us look at the next question. Question 44. A metal M crystallizes in FCC lattice. Consider an atom N which occupies the interstitial site without distorting the lattice. If the edge length of the crystal is 3.61 angstrom and it is given that N is the largest atom that can fit in the interstitial site, then the radius of the atom N is. So students, the examiner wants us to comment on the largest atom which can fit into an interstitial site in an FCC lattice without distorting the lattice. So obviously the atom N will have to be present in the octahedral void. So we can say that the R of atom N will be related to the radius of the metal M as Rn by Rm equal to 0.414. Now we have to find out the value of Rm, and for that value we have been given the edge length of the crystal. So we know that in an FCC crystal, the edge length A and the radius of the atom forming the lattice are related as root 2A is equal to 4R. So R will be Rm in this case. So which will simplify to give us Rm is equal to A upon 2 root 2. Okay. The value of A is 3.61. Okay. And now we can put the value of Rn obtained here in this expression to get the value of Rn. So Rn is equal to 0.414 into the value obtained here, which is 3.61 upon 2 root 2. So this on simplification will give us a value of 0.53. So the correct answer for this question is option 2. Let us look at the next question. Question number 45. Consider the first order gaseous phase decomposition reaction in which 4A is converting into B plus 2C. At T equal to 0, the pressure inside a container with only A present was 1600 torr, and after 10 minutes the pressure reduced to 1300 torr. What is the half-life of A? So students, let us try and solve this question. 4A giving us B plus 2C. So initially the pressure was 1600 torr. 1600 minus 4P will give us P and 2P. So it is given to us that the value of the total pressure after 10 minutes is equal to 1300 torr. So we can solve the value of P from this information given to us. So 1600 minus 4P plus P plus 2P is equal to 1300. So the value of P will simplify to be equal to 300. So students, we can see that the pressure of A is reduced to only 400 torr after T equal to 10 minutes. So we can directly find out the value of half-life of this reaction from this information, as the pressure falls from 1600 to 400 in 10 minutes. So there are two half-lives involved in this. 1600 to 800 will be one half-life, whereas 800 to 400 will be another half-life. And we know that in the first order reaction the half-life is constant. So if we call the half-life of the reaction as T half, we have 2T half is equal to 10 minutes, which implies T half shall be equal to 5 minutes. So students, the correct answer for this question is option 1. Let us look at the next question.